right, hopefully everybody is ready. You've got your note page downloaded into Notability. You have your calculator out, ready to go. And one change we're making today is that these notes are due at the end of the period. You need to upload these notes to Canvas as proof that you took notes today, that you paid attention, you were engaged in class, that you were following along with the assignment. If you need to ask the teacher to pause the video because you missed something, that's fine. But these notes will be due at the end of the period, and there will not be any late or makeup work accepted for that. All right, it's really important that you have a really good understanding of what we're going to work on today. Before we try something new, let's review yesterday, what you should have learned. So yesterday you learned how to solve problems that look like the ones that are on the screen, and you do that by using the square root to reverse what's going on. Unfortunately, on your homework, a lot of you never showed any square roots. You did a lot of it in your head. These problems might be easy enough for you to do in your head for now, but they're going to get more and more challenging. So you have to practice showing your square roots and showing your steps right now, so that as you're prepared for the next thing that comes. If you've gotten sloppy habits now, then you are going to struggle when we get, to the next thing. So let's practice our good habits. We want to use a square root to undo or cancel out the square, and we do that on both sides. And what that does is that gets m by itself. And the square root of 81, you may use your calculator to do that if you don't know it off the top of your head. One of the answers to this is that's the square root of 81 is 9, but there is always a second answer. Every positive square root has two answers. And again, on your homework, a lot of you just did one answer and you just completely ignored the fact that there were two. There is a second answer, which is 9 and negative 9. There's always two when you have a positive and a negative. The reason you always have two is proved by a graph. Okay, that's what you were working on before, that graphs cross the x-axis when they are U-shaped like that. They don't cross them one time, they cross them twice. And so that's why positive roots always have two answers. With the next problem, we need to show a little bit more work, and I need you to show me your steps. Okay, don't do your homework right on top of the textbook. Get a separate piece of paper so that you've got space and write out your steps on both sides. So you want to show that you're adding 180. And then you can show that they cancel out on one side, leaving you with 5r with a square on it, and then 180 on the other side. Your next step is to cancel out the 5. You cancel that out with a division, which you want to show on both sides. On one side, the 5 on the numerator reduces the 5 in the denominator. That still leaves me with an r with a square on it. Some of you lost your square. That square is still there. And 180 divided by 5, you probably want your calculator for that, that's 36. The next step that we show is the square root step. And we do that on both sides. And then we get down to r equals. And again, we have the positive value, but we also have the negative value. 6 and negative 6 are both the solutions to that. Okay, that was using the square root method. Now we're ready to move on to the next method, but we've got to make sure you remember how to do something called the star method for factoring. All right, the star method is when you have squares that don't square root nicely, but it's got something like this. Let me show you. Let's review how to do that. So 6x squared minus 7x minus 5. We need to find out what times what makes this algebraic expression. And the way you worked on this with Mrs. Graham is something called the star method. So maybe when I'm drawing this, you're going, oh, yeah. Okay, well, let's review how that all goes and where all the pieces go. All right, every piece has a name. There's part A, there's part B, there's part C. All of these parts have a name, and they all have a place to go. The A part goes actually in two places. It's so important that it goes twice. And it's going to go here. And then we're also going to have 6x on the other side. So it's a square, which means it's multiplying by itself. So there's two of them, 6x on one side, 6x on the other side. The -7, the b, that goes in the bottom. Remember, b for bottom. If you can keep that straight, then you'll have -7 going down here. What goes on the top is a combination. It's the a combined with the c. Those two things go together. So it's the 6 combined with the -5. That's multiplication. 6 times -5, so we get -30 on the top. And now the real fun starts, where you look at these two numbers, -30 and -7. There are two numbers out there that multiply to make -30. And then they also add up to make -7. So you go through all the ways you can think of to make -30. Could it be -1 and +30, or +1 and -30? Could that be it? Could it be -2 and 15, or could it be -15 and 2? Could that be it? Could it be -3 and 10, or could it be -10 and 3? Could it be -5 and 6, or could it be -6 and 5? Those are all the ways that you can come up with -30 as a multiplication, but only one of those ways also adds up to -7 at the same time. So if you look at all those combinations and change them all to addition signs, only one of them adds up to the right thing. So that's -10 plus 3. So going back to our star method, let me clean this up a little bit, get rid of my big yellow bubble I made there. Okay, that's where we're going to use the -7 and the 3. So -10 goes here, and -3 goes there. We're really close to having our answer now. We just have to reduce, because there's a lot of even numbers going on here. So let me kind of zoom in on this a little bit. And I notice that 6 and 10 are both even numbers. Remember, this was a 6 with an X on it. 6 and -10 are both even numbers, so we can reduce them both by 2. So I can reduce that to a 3, and I can reduce that to a 5. So I have 3x and -5. On the other side, 6 and -3 can be reduced by 3. That's what they have in common. So when I reduce 6 by 3, I get 2. And when I reduce 3 by 3, I get 1. So now I have some new numbers to work on. So let's kind of summarize that a minute. Let's take a look at what we have left. We ended up with a 3 here and an x, and a -5. And we ended up with a 2 here with an x, and a -1. That's what we ended up with. Okay, I'm done with the -30 and the 7. I've already used those up. But these produce your results. These are what are called your factors. And so this 3x and -5, that becomes the answer, 3x minus 5. That's called a factor. And then 2x minus 1, that becomes the second factor, 2x minus 1. Now, none of this should be brand new. This should just be review. You're like, oh yeah, I did this before spring break, long time ago, so we're just getting it fresh in our minds. So that remember, this is called factoring, and you got to be good at factoring so that you can do what we're going to do today for homework. So let's practice one more factoring problem. So let's call this was example number 1. Let's look at example number 2. That's going to be x squared minus 9x plus 14. And I need to turn this into 2 parentheses. And so to do that, I need an A and a B and a C. So let's work backwards. Here's the C, that's 14. Here's the B, that's -9. Now where's the A? The A is a 1. It's not x squared, the a is 1. It has to be a number, okay? It can't be a letter, it has to be a number. All right, well, let's make the star method. And where does the a go first? Well, it's 1x squared, so that's something times itself. So 1x and 1x. Then we do the b term. The b term goes on the bottom, so that would be -9. And then we do the top, and the top is the combination of both the a and the c term together. So the combination would be combining the a of 1 and the c of 14. 1 times 14 is 14. And then we go through the process of figuring out all the things that make 14. So it's 1 times 14 or 14 times 1. Or it's 2 times 7 or it's 7 times 2. But none of those, when I put an adding sign in them, add up to -9. If I change all of those to pluses, none of them make -9. But if I would make -2 and -7 and added those up, that works if they're both negative. So that's the numbers I'm going to use is -2 and -7. Nothing here reduces. There's no numbers in common that, okay, you always look at these these numbers here. None of them reduce. And so I'm ready for my final answer. That would be 1x minus 2. And the other one is going to be 1x minus 7. And those are called factors. All right, so hopefully you're like, oh yeah, okay, I'm remembering how to do that. Now we got to move on to the new stuff. All right, today, the new thing that you're going to take away from today is called the zero product property. And for abbreviation, we call that the ZPP. Okay, the zero product property. What that says is if you have any problem that equals 0, okay, it doesn't matter what the problem is, but if the equal to part is 0, then either the first number has to be 0, the first part of it, so A has to be equal to 0, or the second part has to be equal to 0, B has to be equal to 0, and then I want to put or both could be equal to 0. The zero product property says, okay, so the first part must be equal to 0, or the second part must be equal to 0, or maybe even both of them are equal to 0. So the way we see that is in this factoring that we just got done doing. If the first parentheses is times by a second parentheses and it's equal to 0, has to be equal to 0, then either the first one is equal to 0, x plus 3 equals 0, or x plus 2 equals 0, or both of them could be. So how does that help me? Well, what if it was the first one? What if it was x plus 3 equals 0? How do I solve that? Well, we just learned that we're going to subtract 3 to both sides. That always cancels out. And the answer could be x equals -3. That could be an answer, a solution. But remember, there's always two solutions. So, or the other one might be it. It might be the x plus 2. That could be equal to 0. And so then I would subtract 2 from both sides. And the plus 2 and the minus 2 cancel out. And then I'd be left with x equals -2. That could be the answer. Or both could be the answers. So you have options. Okay, you have choices. That is called the zero product property. But it has to be for a problem that's equal to 0. Let's keep practicing that. What are the solutions of the equation 4t times the parentheses t minus 2 equals 0? All right, good. It's equal to 0. That's what we need. So we can use the ZPP, the zero product property. So that says if you have two parts, now 4t is considered its own part, and t minus 2 is considered its own part. Then either the first one has to be equal to 0, or the second one has to be equal to 0, or both of them. So either 4t has to be equal to 0, or the second one, t minus 2, has to be equal to 0, or both could be equal to 0. So let's solve. If it's the first one, what would we do to both sides? We want to get t alone by getting rid of the 4. The only way to get rid of the 4 is by putting a 4 underneath to divide, and you do it on both sides. That means the top 4 reduces the bottom 4, and we get t equals 0 divided by 4 is still 0, and t is all by itself, so t must be equal to 0. That's the first answer. Or the second answer would be I want to add 2 to make the negative 2 go away, and I do that on both sides. So the minus 2 and the plus 2 cancel each other out, so t is by itself, and now t is equal to 0 plus 2, so t equals 2. That could also be a solution. Or both could be the solutions. So I have 1 or 2 or both of them. So t equals 0 or t equals 2 or both. Let's keep practicing. What are the solutions of these equations? Well, it equals 0. So I can use the ZPP. And I'll take that first part, x plus 1, and maybe x plus 1 is the part that would be equal to 0. Or maybe it's the second factor, x minus 5. Maybe that's equal to 0. Or maybe both of them are equal to 0. But let's solve and see what our options are. So for x plus 1, I'll minus 1 to both sides. The minus 1 and the plus 1 cancel out. That gives me x equals 0 minus 1 is negative 1. That could be a solution. Or the second one could be add 5 to both sides. Then the negative 5 cancels out the positive 5, leaving me x by itself, and 0 plus 5 is 5. Or it could be those solutions, or could be both of them. But I have to list them both as possibilities. For example, B, we again double check. Yep, it's equal to 0, so I can use the zero product property. That means I can take the first part, 2x plus 3, and that could be set equal to 0. Or I could take the second part, x minus 4, and that could be equal to 0. So you've got two problems to solve. This is the kind of work I'm talking about. When I say show your steps, this is what I mean. So then you're ready to solve, and you want to subtract 3. Subtracting 3 will cancel out the 3 on one side. And then we're left with 2x, not plain x, but 2x. So x is not yet alone, so I need to do a second step to divide by 2. And now the 2 in the numerator reduces the 2 in the denominator, so we're left with x equals negative 3 divided by 2. That's negative 1.5 when you check that decimal value for that. Or we could work on the other one. We add 4 so that we can work toward getting x by itself. The -4 and the +4 cancel each other out. So you're left with x equals 0 plus 4 is 4, and x is by itself. So that's the second option. Or both could be possibilities. It's one or the other, or both. So these are how you're going to use the zero product property. But we let you off kind of easy on these because the parentheses were already there as part of the problems. So to make it just a little bit more challenging, we're going to give you ones where the parentheses are not there. So even though you have a zero product property, you don't have any parentheses. You have to create them yourselves. You can't do it without parentheses. So where are you going to get the parentheses from? You're going to need to do the star method to come up with your own parentheses here. And in order to do the star method, you need to know what C is, you need to know what B is, and you need to know what A is. And A is 1 in this case. All right, so we start with A. Remember, A goes 1x, and then because it's squared, there's 2 of them. We multiply it by itself. B goes on the bottom, so that'll be 8. And then the top is the combination of A and C. So 1 and 15 together, which is 15. And then we take that 15 and we think about all the ways we can make 15 with multiplication. Is it 1 and 15 or 15 and 1? Is it 3 and 5 or 5 and 3? Do any of those, when I turn them into addition, if I make it a plus, do any of those work out to be 8? And the answer is yes, we found one. 3 and 5 work out to be 8. So do 5 and 3. You could use either one. So we'll use 3 and we'll use 5. Then we look and we say, okay, do I have to reduce that? And there's nothing that can reduce, so that is my first parenthesis, 1x and a +3. That's my first parenthesis. On the other side, we have 1x and 5. That can't be reduced either, so we have 1x and 5. That's the second factor. We have 2 factors, and it's still equal to 0. So now, I have it equal to 0, which means the ZPP, the zero product property, and I have 2 factors. So now I'm ready to go. I have to get it into factored form first. So now I can take the first factor, 1x plus 3, and I can set that equal to 0. My other option would be to take the second factor and set that equal to 0 as well. And then we'll work through solving those. To the +3, we want to do a -3. So the +3 and the -3 cancel each other out. We have 1x equals -3. To get x totally alone, we want to divide by 1. That makes x totally alone, and -3 divided by 1 is still -3. So that is one possible solution. For the second factor, we'll take -5. That's going to give me 1x equals -5. And we want to get rid of that 1 also, so that x is all by itself. And so x by itself is -5 divided by 1, which is also -5. So these are my 2 solutions, x equals -3 or x equals -5. Or both of them are the solutions. So that's what makes it a little bit harder when you have to come up with your parentheses all on your own. So we're only going to give you in your homework a couple of them that already have the parentheses, but most of them don't have parentheses. Most of them are going to look like this. All right, so we want to find the solutions of each equation. Now all of these are good. They're all equal to 0. So all 3 of these can use the ZPP. However, all of them are missing their parentheses. Okay, this one needs its parentheses. So does the second one. So does the third one. So all of these are going to need to be factored using the star method. So we'll just work on one at a time. To do my star method, I need to make sure I know what A, B, and C are. I always like to work backwards. I say C is negative 14, B is negative 5, A, oh, I need a 1. So since A is 1m squared, I have 1m on this side and 1m on that side. The bottom number would be negative 5. The top number is the combination of A1 and C negative 14. So that will be negative 14. Okay, so now I need to come up with negative 14. Is it negative 1 and positive 14? Or is it negative 14 and positive 1? Or is it negative 2 and positive 7? Or is it negative 7 and positive 2? And then you check the addition. If all of those became adding, one of them adds up to the right number, right? When we make this adding, this is 13. This one is negative 13. Negative 1 plus 14, negative 14 plus 1. Negative 2 plus 7, that's 5. Negative 7 plus 2, that's negative 5. That's the one I want. I want negative 7 and 2. Then we check, all right, for the 1 and the negative 7, is there anything I have to reduce? And there's not. So my first factor is 1m minus 7. And then for the other one, check that out. Nope, nothing to reduce, so 1m plus 2. So now my factoring is done. And now I can use the ZPP, the zero product property. So take each part, or the zero part property. You can take the 1m minus 7 part and put that equal to 0. Or the other solution would be the 1m plus 2. And that would be equal to 0. So we'll solve both of those. Add 7 to both sides. 1m, cancel the negative 7 and positive 7. 1m equals 7. So m equals 7 is the first result. For the second factor, I want to subtract 2. That cancels out the positive and the negative 2, leaving me with 1m equals negative 2. So m equals negative 2. So for example A, those are your two options. All right, let's move on to example B. Again, I have the zero product property, the ZPP, but I don't have the parentheses. So my job first has to be to find the star factors. And I always work my way backwards. C is going to be negative 20. B, what's that going to be? Well, that's going to be 1. If the number is ever missing, then you know the coefficient is 1. And then A, that's also going to be 1. So we'll fill them in, starting with A. That'll be 1p, and the other side is also 1p. That's the squared. One thing times itself. The B number goes on the bottom. That's a 1. And the C number, the combination of A combined with C makes negative 20, and that'll be on the top. So now we got to go through all the ways to make negative 20 that might also make 1. So is it negative 1 and positive 20 or negative 20 and positive 1? Is it negative 2 and positive 10, or is it negative 10 and positive 2? Is it negative 4 and positive 5, or is it negative 5 and positive 4? Those are all the ways that we could multiply to make 20. Now we want to turn all those into plus signs and figure out which one is going to add up to positive 1. And it's the negative 4 and the positive 5 combination. So I have negative 4 and positive 5. All right, 1p minus 4 becomes the first factor, 1p minus 4. 1p and positive 5 become the next factor of 1p plus 5. And now you're ready to take each of those factors and set them each equal to 0. So 1p minus 4 has to be equal to 0, and 1p plus 5 has to be equal to 0. Those are your two. Add 4. Cancel out the negative 4 and the positive 4. That gives you 1p equals 4. So plain p has to be equal to 4. Or the other answer, we're going to subtract 5 and cancel out. Again, this is what I mean by showing your steps. So 1p equals negative 5. So p has to equal negative 5. So our two solution possibilities are 4 or negative 5. All right, here's the last one. As we finish this one up, we have to find our twos, our final one for practice. We're going to find our two factors, and we have to do that using the good old star method. Again, I like to identify everything. Here's the C, here's the B, here's the A. The A part is 2a squared this time, so I need a 2a in both of them. The bottom would be negative 15, and the top is the combination of A and C. So that's a 2 and an 18, so that's going to be 36. And that will go in the top. That's one of the most common mistakes, is that a lot of people would just rush and they'd accidentally put 18 on the top instead of realizing it's really supposed to be 36. Okay, now we need to go through what are our choices for 36. So is it going to be 1 and 36 or 36 and 1? 2 and 18 or 18 and 2? 3 and 12 or 12 and 3? 4 and 9 or 9 and 4? Or 6 and 6? There are a lot of options for 36. None of those are going to make negative 15. So then I need to try with some negative numbers. So what if I make them all the parts to be negative? Can I find one that with negative numbers and addition signs, right? Remember, we're changing those all to addition signs as well. Could we find the one that's going to make negative 15? So I can see it right now. I can see that this one is going to be negative 15, negative 3 plus negative 12. But you know what? So is negative 12 and negative 3. That's also negative 15. So either one of those would work. I've got two possibilities that would work, and either one is going to be fine. So I'm going to use the second one for this one. So I'm going to use negative 12, and I'm going to use negative 3. Now, when I'm ready to take a look at the 2a and the negative 12, I notice both of them are even numbers. Then if both of them are even, they can be reduced. You always got to check that. So 2 and negative 12 can get reduced. That gets reduced to a 1, and it gets reduced to a negative 6. So my factor is now not 2a minus 12, but 1a minus 6. That's another tricky spot you got to watch out for. Some people will just go get really in the habit of 2a minus 12. They think that that's the answer, but it's not. Okay, that's a bad habit. So a good habit is to make sure you always check to reduce. Now 2a minus 3, those don't reduce. 2 is even, 3 is odd, minus 3 is odd, so they don't reduce. So that gives me 2a minus 3. All right, well, that was the hard part. That was the hard work, was getting those factors. Now that I have those factors, I can use the zero product property, okay, the ZPP, and now I can take 1a minus 6 and I can set it equal to 0, or I can take 2a minus 3 and I can set that one equal to 0. Then we're pretty much in the home stretch. We add 6 to both sides. We reduce. That gives me 1a equals 6. And if 1a equals 6, then a equals 6 is the solution. What's the second solution going to be? So we add 3. The minus 3 cancels out the plus 3. That leaves me with 2a equals 3. And that doesn't yet have a by itself. So I need a second step of dividing by 2. And the top 2 and the bottom 2 reduce. Now a is by itself, and I get 3 divided by 2. You can leave that as the fraction, 3 divided by 2, or you can write it as the decimal, 1.5. If I was your permanent teacher, I would have you leave it as the fraction. But we'll let Miss Graham decide if she prefers the fraction or the decimal. I prefer the fraction because it's better for the future, but we'll let Miss Graham decide. She'll probably accept both for you. All right, that's where our notes are going to stop today. And hopefully you got all of those, because what I want you to do right now is to stop and upload these pages to the notes section in Canvas so that I can give you, it's basically free points. If you paid attention and you copied everything, you'll get the free points for today, which will help some of your grades. Some of you need a little bit of a grade boost. If you did not get these, or you kind of zoned out and weren't paying attention, you can log in and watch the video yourself in Canvas, or you can get what you need from a friend. But I want to hold you accountable for taking these notes today. Okay, for the rest of the class period, you are going to be working on practicing this skill by yourself. And then on Friday, we're going to add a little twist to it and have you kind of tackle something a little bit more challenging once you've had a chance to practice this. All right, good luck. Feel free to send me, Mrs. Pfeiffer, an email, or ask your sub if you need help from him, and we'll get all this done together. All right, thanks. Have a great rest of your block day.